Hey, Team 701, Mr. Murphy here. We're talking about wind today. This little YouTube video is going to go with your notes. So let's get that right there. I printed these off. You're welcome to print them off. You can also do them digitally. You can put two screens on your browser at one time. You can do that. And we're talking about this wonderful thing known as wind today. And wind is moving air. You know that. I love this drawing because we got my high pressure. And it almost seems like wind wants to run up this teeter-totter to the low pressure. All right. What is wind? These are the goals of the day. What is wind? What causes it to blow? We all know what it is. Well, it starts back with a little bit of review. So we need to review some stuff. We know that cold air sinks. Well, why? Cold air sinks because it's more dense than air. And warm air rises because it is less dense than air. That's just review. Do I need to do the convection dance? Maybe you could do, I'll hit pause right now. Maybe you could do the convection dance at home. Say I whispered it so you could fill in the voice. Okay, so this is a crazy infographic, and you've seen the picture on your paper right now, and it's super important because here's how air moves. We know, and I'm going through the steps right now. It starts with number one. Solar energy is going to reach the sun via radiation. That's going to heat up the ground. Then we're going to start to see warm air rise. Well, we know that warm air rises because it's less dense, those molecules are going crazy. Well, then they get higher up in our atmosphere. Our atmosphere up high is cooler. So then they start to sink. So if you recall, we were drawing like little convection currents, looks like this, drawing right here, warm air going up, and then it cools down and sinks. That is moving air, and that is exactly what happens in our atmosphere. So air pressure and air density, my friends, are very similar. In this case, I'm going to teach them as basically being the same, and they're not quite the same, but I think it's easier for seventh graders to understand. So air pressure is the weight of the air in this room. Okay, we've done this in class. Hold the air. Man, I'm holding hundreds of pounds of air. If I go outside and look up, there's the weight of like 3 elephants on top of me because we know that air has mass. And we'll talk in class about why, the elephant mass doesn't crush us. But air pressure is created by the weight of an air molecule pressing down on Earth's surface. That's important because air always moves from high to low pressure. And I'm writing that down in my notes right now that I have printed off. And that is like your ding, 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 super important thing of the day. Air moves from high to low pressure. You could also read that as air moves from high density to low density. Kind of looks like this. All right, I got a balloon. All right, here's a balloon. Think about it. I just put a whole bunch of air inside this balloon. This air is really dense, right? Right. Well, when I let it go, it makes that funny noise, and obviously the air rushes out. This is exactly what happens in our atmosphere. This high density air, or high pressure air, wants to get to the areas of low pressure surrounding it, which is everything outside. So what happens when I let it go? It escapes. It flies around. Air moves from high to low pressure. What actually is wind? I mean, come on, this is easy, people. Wind is air moving, and it's caused by uneven heating of the surface, which causes pressure differences. Remember, pressure can also be said as density. We know that different temperatures of molecules have different densities. We've done experiments in class. We've talked about it for about a week and a half now. So what causes air to move? Density changes. In the weather world, we call it pressure differences. Different pressures means air is going to move. So here's what I would like you to do now. So I'm looking at my sheet right now. I have 3 videos for you. They're linked on your Google Doc. So if you printed out this document, that's fine. I still want you to go into the Google Doc and watch the videos. So these links are pretty cool. So think of this as kind of like an interactive, you're listening to me. You also got other outside videos to watch. I didn't link them on here because I thought it'd be easier. So check it out. Check out those videos, and I'll see you in a second. So I said air moves from high to low pressure. So it looks like this. So imagine, and you might have seen a weather map like this before. So imagine you had a big old high pressure system right here. And let's imagine that these areas were low pressure. And if you looked at a wind map, guess what? The wind would be blowing from high to low pressure. Think of it just like the balloon. The H is the inflated balloon. There's a lot of air packed inside that area. That packed air wants to go to areas where it's less packed. It wants to spread out. So air always moves from high to low pressure. And this crazy map, which you've probably seen these before, this would be the weather map from Monday, October 5th, shows you that. So I could bet you, and I can guarantee you, that these areas of high pressure, the wind was blowing this way because air wants to move from high to low pressure. Hey, we're in Ohio, chilling. Hey, there's me. Anyway, we had a high pressure area on Monday, but our air wanted to go to this lower pressure area. The greater the density difference, the faster the wind blows. If it's a very calm day, it means the air is pretty stable. It has approximately the same density. If you remember on Monday, group A people, we went outside. It was super calm. There wasn't very wind, or there wasn't much wind. We lit up that lantern, that hot air balloon. It was super calm. On Tuesday, it was super windy. I just remember from football practice, very windy. So there was a greater density difference or pressure difference on Tuesday than there was on Monday, and we could feel that as wind. We also got some special types of wind, and we're going to talk about this thing known as the Coriolis effect. On your Google Doc, I put a link. Oh my gosh, what's the time up? It says watch this video first. I would like you to watch that video first. So pause me, watch the video, then come back to me. If you printed it off, pause me, watch the video, come back to me. So the Coriolis effect, that's the influence of Earth's rotation. We know that the Earth is constantly spinning. It spins once a day, in case you were wondering. Call it a day. Get it? Okay. The spinning influences our wind. And you notice here on the drawing is our winds do not move in a perfectly straight line because the Earth is constantly spinning. So the influence of Earth's rotation, which changes the direction of winds and other objects moving on Earth. The video above does a phenomenal job of explaining that. So in the northern hemisphere, winds curve to the right. And in the southern hemisphere, winds curve to the left. And what I always think of it, you notice that it's hurricane season right now, is hurricanes in the northern hemisphere tend to always move in this direction. Screw that up. They always move in this direction. And that is due to the Coriolis effect. In the southern hemisphere, they rotate the opposite way because of Earth's constant rotation. It affects only winds that travel super far distances, so it's not like if you were sitting on the atmosphere, or excuse me, it's not like if you were sitting on the equator, you'd just be like floating there. No, but winds that have winds that are very powerful or winds that blow across the globe, they're going to be bent by the Earth's rotation. Winds cannot flow from the poles to the equator. They have to travel in each hemisphere through routes called wind belts. And back in the day, I used to memorize wind belts. We're not going to have you do that for obvious reasons. Okay. And here it is, this wonderful hurricane. You'll notice that it's spinning like this in the northern hemisphere, and it's spinning like that in the southern hemisphere. Another cool little example here of the Coriolis effect with this storm spinning in this rotation due to the Earth's constant movement. We also got these things known as local winds. Pretty darn cool. So some winds, they change daily. If you've been to the beach, you might have noticed this. You can even go to, so like I was recently at Lake Michigan, which is not an ocean. It's a really big lake, but you can feel the difference in the night and in the day because that body of water is so large. If you've been to the ocean, recently or have ever been to the ocean, you can tell that the winds are going to change daily. And we call these local winds, and they change in predictable patterns. So we have this thing called a sea breeze. That's where warm air on the shore rises during the day and cooler air from the water blows on the shore. And I added this little note in. So what happens is during a sea breeze, the high pressure or more dense air is over the cool water, and the low pressure or less dense air is over the land. So guess what? It makes this wonderful little circular movement. Because air wants to move from high to low. Air wants to move from high to low. Air wants to move from high to low. Well, at night, that thing switches. Because what happens is the water stays relatively the same temperature, and the land is going to cool down rapidly. So now the water is a bit warmer than the land, and the cycle flips itself. The high pressure is over the land, the cooler pressure is over the water, so the air is now going to blow out from the land. And I want you to think, last time you're at the ocean, if you experienced that, I know, like I said earlier, I was at Lake Michigan this summer, and it was really interesting because the winds basically flipped about halfway through the day. In the morning, we'd have that sea breeze, and then as it got cooler at night, this land breeze came, and it was pretty darn neat. And it also sadly affected my golf game. And a wonderful little picture to go with it. I forgot to mention there was a sea breeze video that I would like you to have watched first. And that, Team 701, is wind, the basics. You're watching this on either Thursday or Friday. I'm looking at my calendar, the 8th or 9th. We'll be talking about air pressure in class during those days, and we'll be talking more about wind next week. I hope you learned something. If there's an issue, Schoology message me. Thank you so much. Thank you for being an accountable, responsible, respectful student, and I appreciate you. Have a great day. See ya.